I bought this fixture, maybe 3 years ago. I'll put it in post exactly when I bought it. I did a review on it though, so you can look at that review. That's about when I bought it. The review was maybe a month after I bought it. And in the review I showed that it worked for 71 watts. Didn't pull 100 watts. Pulled, supposed to be a 100 watt unit. Fairly big guy. But yeah, only pulled 71 watts. So in the review I saw that one row of LEDs was out. And I showed that on camera somehow. So that might be why it was only drawing 71 watts. And we didn't think it would last very long. It did last a couple good winters though. It died maybe a month ago now though. It actually probably died in September, I'd like to say. Maybe a couple months. And died completely. I didn't lose more rows and then it went out. It just one day didn't work. On the kilowatt I have 0.3 VA, 0.2 watts, 120 volts. So I removed all except for the last screw on each cover. This one's kind of not too surprising. In fact, a little bit of flex there may even keep it tighter, But look at this one. I really have to push hard to get this to close. You can see the whole screw there flexes when I do it. There's some precision for you. Sorry about the lighting change here. My favorite light went out. I built this way back, probably in Hiller Stream channel, before I started this off branch of my electronic stuff. So I smelled something burning, and I didn't have anything really plugged in here. It was my light was burning. This is something I made way back before I had this channel going. I had my Hiller Stream channel. All my electronic stuff was on Hiller Streams. And it still does work, but the fan died on it. This is my main light for shooting over here. I'll have to figure that out. Anyway, it was overheating and the resistors were stinking. So it kind of stunk up the room, even though it still works. Well, I've got a basic math problem with this fixture. Okay, so we've got 27 to 36 volts. Let's say 36 volts, give it the best possible number here, times 2400 milliamp, so it's 2.4 amps. 36 times 2.4, well, that only gives you 86.4 watts. So right off the bat, we're mathematically challenged. So that 71 I was getting with one bar missing, the best it would have ever done would be 86 under ideal conditions. So that's a fail right off the bat. And I've got screws in all four corners. That's kind of rare for these fixtures. Usually they leave half of them out. Try to save anything they can save. It seems to me that the fixtures that I've bought over the years, the first ones I bought were the best ones. The later ones just got worse and worse. So it's kind of a free-for-all in the market, I guess. People coming in and saying, hey, I can do that, and doing it poorly, even among the Chinese. Because I was finding things like, power supplies not glued in well, not glued in a way to get rid of their heat. But worse than that, poor soldering, poor heat sinking on the chip, hardware not really fitting right, so the heat sink couldn't work right on the one I had. A variety of really simple issues, some going down to fit even. But really a big thing, if the the chip can't get rid of its heat, you're in big trouble. And it should be on. Let's see what kind of voltage we get here. Not sure what's going on with that probe. I better set of Mueller probes. God, they're expensive nowadays. I want to buy some good probes for these cheap meters. You pay more for the probes than you paid for the meter. I guess that's what happens when you buy cheap meters. Alright, so this should be DC. 47 volts. 47.7. Right off the bat, that's too much voltage. This power supply is only supposed to do 36. There's no load, so maybe we can forgive it. It's possible that this inverter is not actually the problem. It might just be the chip that died. Sure looks like it. The chip should be lighting up or doing something. All repaired. A little mechanical thing I didn't see interfering with the fan. My favorite light lives again. So everything in this is pretty good. I mean, the quality is better than most of these fixtures. All four screws were in the die, A lot of times you see them only do 2, just like they do the cover only 2 sometimes. One screw was stripped, but despite that, you can see there was good coverage with the heatsink compound. So there really wasn't any failure there. So I guess the only thing left to do is to dummy load this power supply and see if it does a reasonable amount of voltage. I can't accept 47 volts, but I think under a load it'd probably disappear. We'll have to check that out though. So yeah, the only thing left to do is dummy load the supply. The only load I got big enough for that is, of course, my speaker, my audio dummy load. Okay, we've got almost 48 volts here. And then if I put a load on it, I end up with a 200 ohm load on for starts. I think it's actually like 209 or something like that when I measured it. And I'm still doing 44 volts. So I'm kind of getting edgy about this power supply now. It should limit me to 36 volts. It's not doing it too well. Let's increase the load, see what happens here. And I'm going to probably go all the way down to 8 ohms, or maybe even 4 ohms. At which point this should be limiting its current output. Well, let's see what happens live here. 8 ohm load. It shouldn't do its full 36 even because it's too much current. Yeah, I'm getting a bouncy output. If I can hear the thing. Alright. And now we'll try it with a 16 ohm load. Yeah, it's still bouncing. Well, 37's pretty steady, 37. So this is balanced working, not working great, but still a little bit hot, even at 16 ohms. Less of a load than it would have. It would have a bigger load. See if it was 10 ohms. 36, you do 3.6 amps. And this thing's supposed to limit me to 2.4 amps. Again, at 8 ohms or 8.6 ohms, whatever it is. No, it can't even hold that. Of course, it shouldn't, because that'd be 4.5 amps. So it needs to limit that a little bit. I want to measure current at 16, make sure it's limiting current to some degree. Maybe I'll buy a 100 watt chip for it. Not that expensive usually. If I could find a decent one, that would be the trick. So quick calculations. 100 watts, it's a 100 watt fixture. So if you divide that by 25 volts, you need 4 amps. If you divide that by 36 volts, you need 2.777777 amps to make that 100 watts. So if you divide that out, E divided by I, you get resistances, depending which numbers you use, 36 divided by, 36 divided by 2.7 versus 25 divided by 4. So I'm well within that range. I got a 13 ohm load, roughly. That's what I measured. It should be like 15 or 16, actually. At any rate, it should be able to support this if it's not. You can see my current and voltage is just zigging around. So this inverter's got to be called bad, I guess.